Good evening, everyone. Today, our team going to explain 2.7 question, that is a linear system. S has the relationship y of n equal to summation k equal to minus infinity to infinity x of k into g of n minus 2k between its input x of n and its output y of n, where g of n equal to u of n minus u of n minus 4. We need to find the solutions for these four subparts. Determine y of n when x of n equal to delta n minus 1. Determine y of n when x of n equal to delta n minus 2. Is S is linear time invariant. Determine y of n when x of n equal to u of n. For the first subpart, given that y of n equal to summation k equal to minus infinity to infinity x of k into g of n minus 2k. In this question, they have given that x of n equal to delta n minus 1. Therefore, here I am replacing n by k. Then x of k becomes delta k minus 1. I am substituting x of k in equation number 1. Then y of n equal to summation k equal to minus infinity to infinity delta k minus 1 into g of n minus 2k. Where delta k minus 1 is an impulse function. Therefore, if k equal to 1, it will becomes 1, otherwise it will become 0. So I'm substituting k equal to 1 in this equation. Therefore, y of n equal to summation k equal to minus infinity to infinity g of n minus 2 into delta k minus 1. We know that summation k equal to minus infinity to infinity delta n becomes 1. So I'm substituting 1 in this equation in place of delta k minus 1. Then the equation becomes y of n equal to g of n minus 2. In the question, they given that g of n equal to u of n minus u of n minus 4. I'm substituting again n equal to n minus 2. Then it will become u of n minus 2 equal to u of n minus 2 minus u of n minus 6. Where here u of n minus 2 and u of n minus 6 is an unit step function. Therefore, if n greater than or equal to 2, it will becomes 1. Otherwise, it will become 0. So u of n for this u of n minus 2, the plotting will look like this. From 2 onwards, the amplitude becomes 1 up to infinity. For n minus 6 also, when n greater than or equal to 6, it will becomes 1. Otherwise, it will become 0. So the plotting will look like this for u of n minus 6. From 6 onwards, it will becomes the amplitude becomes 1 up to infinity. The final equation is y of n equal to g of n minus 2 equal to u of n minus 2 minus u of n minus 6. Here we are subtracting u of n minus 6 from u of n minus 2. The plotting will look like this for this y of n equation. For the second subpart, determine y of n when x of n, the input x of n is your delta n minus 2. Here we are changing the input as x of n equal to delta n minus 2. Again, I'm substituting in place of n, I'm substituting k. Therefore, x of k becomes delta k minus 2. In place of x of k, I'm substituting delta k minus 2. Then the equation becomes summation k equal to minus infinity to infinity delta k minus 2 into g of n minus 2k. So as usual, it is an impulse function. Therefore, if k equal to 1, it will becomes 1. Otherwise, it will become 0. Therefore, the equation is the summation k equal to minus infinity to infinity g of n minus 4 delta k minus 2. Here I have substituted k equal to 2. Therefore, I got 4 here. And we know that again summation k equal to minus infinity to infinity delta n becomes 1. I'm substituting 1 in this equation. So I got y of n equal to g of n minus 4. We know that g of n equal to u of n minus u of n minus 4. I'm replacing n as n minus 4. Therefore, g of n minus 4 equal to u of n minus 4 minus u of n minus 8. So u of n minus 4 becomes, it becomes 1 if n greater than or equal to 4. Otherwise, it will become 0. So the plotting will look like this for this unit step function. And again, for this unit step function, it will becomes 1 when n greater than or equal to 8. otherwise it will become 0. The plotting will look like this. The final equation is y of n equal to g of n minus 4 equal to u of n minus 4 minus u of n minus 8. Again, I'm subtracting u of n minus 8 from u of n minus 4. The final plotting will look like this. And my friend will explain this C subpart.
So to check the condition of LTI for the given system, we need to let's consider the cases of A and B, which the in case A, the input is taken as delta of n minus 1, and in the case B, that is delta of n minus 2. In here we can observe that the input of B is nothing but input of 1, which is shifted by 1 time, and the outputs are as follows for x1 of n, that is in case A for delta of n minus 1 we got the output of g of n minus 2, and the case B for the input of delta of n minus 2 we got g of n minus 4. This we can write as y1 of n minus 2. That means the when the input is delta of n minus 1, from that output the time is shifted for by 2, but the input is shifted by 1. If the system is time invariant, the output should also change by time as changed by the input, but here in this case the condition has failed, so we can say that uh, the system is LT, not in LT.
Now let's see the D part of the sum. The D part of the sum is determine y of n when x of n is equals to u of n. We know that x of n is equals to u of n. Therefore, x of k is equals to u of k. The value of x of k is equals to 1 when k is greater than or equal to 0 and 0 otherwise. Now, let's see g of n. G of n is equals to u of n minus u of n minus 4. Let's plot the graph for u of n. Let's take the axis. We know that u of n is equals to 1 when n is greater than or equal to 0. So the graph will be like this. 1, 1, 2, 3, and so on. Now let's plot the graph for u of n minus 4. We know that. Let's take an axis. We know that u of n minus 4 is equal to 1 when n is less than, greater than or equal to 4. So let's get a graph like this. 1, 2, 3, 4, 5, and so on. Now let's subtract the u of n minus 4 from u of n. By subtracting them, we will get a graph like this. 1, 1, 2, and 3. From the above graphs, we get a z of n value. That is, z of n is equals to 1 when the limits of n is 0, less than or equal to n, less than or equal to 3, and 0 otherwise. Now, let's see for the z of n minus 2 minus 2k. For z of n minus 2k is equal to 1 when the limits are 0, less than or equal to n minus 2k, less than or equal to 3. After simplifying the limits, we will get the limits like this. N minus 3 divided by 2 less than or equal to k less than or equal to n by 2, like this, and 0 in the other cases. Now let's plot the graphs to see whether the graphs will be overlap or not. In the case 1, we see that n by 2 is less than 0, where n is less than 0. After plotting a graph of x of k and z of n minus 2k, we will see that the values should be less than 0, means n by 2 should be less than 0. So we see that there is no overlapping between these two graphs. There is no overlapping. Therefore, the y function y of n is equals to summation of k minus infinity to the infinity x of n z of n minus 2k is equal to 0. Now, let's see the case 2. Now, let's see the case 2. In the case 2, we will see that n minus 2 should be greater than 0. Therefore, n greater than 0. N minus 3 by 2 should be less than 0. Therefore, n minus 3 should be less than 0. N should be less than 3. From the above 2, we will get the limits like this. 0 less than n, less than or equal to n, less than 3. After plotting the graph x of k and z of n minus 2k, we will see there is a overlapping. Here at 0, here at n minus 2k. We will see that there is an overlapping here. So the y function will be summation of k0 to n by 2, 1 into 1, that is equals to upper limit minus lower limit plus 1. So we will get n by 2 plus 1 is a final answer. Then let's see for case 3. For case 3, the n minus 3 by 2 should be greater than 0. Therefore, n minus 3 should be greater than 0 and n should be greater than 3. After plotting the graphs of x of k and z of n minus 2k, we will find there is an overlap here and here, where the limits are n minus 3 by 2 and n by 2. So the y function will be y of n is equals to summation of k is equals to n minus 3 by 2 to n by 2, 1 into 1, that is equals to upper limit minus lower limit plus 1. This is the case we use here. Upper limit minus lower limit plus 1. Later, we will get the result like this. 3 plus 2 by 2. So the answer is 5 by 2. So later, we will get the values of y of n function. The y of n function is 0 when n is less than 0. And the function is n by 2 plus 1 when the limits are 0 less than or equal to n less than 3. And the value is y by 5 by 2 when n is less than or equal to 3. So using these values, let's plot a graph. So now let's take the axis. So when n is less than 0, the all values tends to be 0. When n 0 is less than or equal to n less than 3 is equals to n plus n by 2 plus 1. That implies when n is equals to 0, n by 0 by 2 plus 1 is equals to 1. When n is equals to 1, 1 by 2 plus 1. That is 0.5 plus 1, 1.5. When n is equals to 2, 2 by 2 plus 1, that is equals to 1 plus 1, that is equals to 2. Now, for n greater than or equal to 3, the value tends to be 5 by 2, that is equals to 2.5. Using these values, let's plot the graph now. As we all see, at the value 0, the value is 1. At 1, the value at 1, the value is 1.5. At value 2, the value is 2. At value 3, the value is 2.5. And 4, the values which are n greater than or equal to 3 is equals to 2.5. So it tends to so on like this. So that's the final answer. The y function is this. So thank you for seeing. So these are the teammates which done this video. Thank you.